Do you like adding fractions? It's probably not something you think about much, but take it from me. Somebody that uses one of these every day, nobody likes adding fractions. In fact, back when scientists were trying to come up with an international system of measuring so that all different countries could communicate better scientifically, they decided that they would shy away from a fraction-based system of measurement, and they would develop a decimal-based system. Now, a decimal-based system, that's probably not a term you hear often. So what is a decimal-based system? Well, let's compare. This would be a fraction, 7/8. So that we don't want to look at numbers. Scientists decided we don't want to look at numbers like that. We'd prefer to look at a number like 7/8 in terms of a decimal, which would be, this is the decimal equivalent of 7/8, 0.875. So this was over 200 years ago. Scientists decided we would prefer a decimal-based system. So in the next couple of minutes, we're going to talk a little bit more about that system. That system, by the way, is called the International Standard System of Units. International Standard System would probably sound like IS, but it's not. It's SI. So the International Standard System is SI. We also know it, I more commonly refer to it as the metric system. So we're going to talk a little bit about, I'm going to try to make it quick. I want to talk about where it came from. So why, not so much why, but where and how we got our standard systems or our standard system of measurements that all the scientists agree on. Where did it come from? So it came from, real quick, we'll start with the meter. This is a very modified yardstick. I put an extension on it so that it's just over 3 feet. If you talk more in terms of feet, it's 3 feet, almost like 3 feet 3 inches about. So that came from back in 1791. France decided to hire 2 astronomers. Also, I guess for their day, they were surveyors. These are people that would plot land. And I guess they did it with the stars, which is why they're astronomers. So these are the guys. I don't know if you can see it. I'm going to try to pronounce their names. Jean-Baptiste Joseph Delambre and Pierre-François André McCain. So these 2 guys came up with, Jean-Baptiste went north out of France. He went all the way north. He didn't go to the equator. He didn't go to the North Pole. And Pierre-François theoretically went down. For this demonstration, let's assume this guy went all the way to the North Pole. This guy went all the way to the equator. Why do I say we need to assume that? Because when they were done with their research, they came up with exactly the distance from the North Pole of our Earth to the North Pole to the equator of our Earth. Why did they do that? Because they figure our Earth isn't changing. People, for the rest of our lives or the rest of the world's lives, we will always be able to measure that. They came up with that distance, and they came up with this, the meter, which we just talked about. This is it. This is the distance. Well, wait a minute. That's too small. That can't be the distance. No, it's not the distance. But they took that number and they divided it to get this. They divided it by something. What did they divide it by? I heard someone. You said 10 million. 10 million. Yes, this is. Nobody said that. This is exactly 1/10,000,000th the distance between the North Pole and the equator. Now, why is that important? It's important just because, or I don't know why it's important now, but it was important. And I guess it's the same reason, really. Because the Earth theoretically will always be there. You'll always be able to trace this back. So they wanted an exact distance. Now, that's how we internationally measure length. I'm going to try to fit in how we measure weight, and I'm going to try to talk about why we measure volume also. So really quickly, you take this. So this is a decimal-based system, right? Why is it a decimal-based system? I'm sorry if you can't see this whole thing. We took this 10 millionth and we divided it by 100. Why did we divide it by 100? Well, that's what makes the decimal-based system. So now each of these is a decimal. This is 0.1 meter or 0.01, 0.02, all the way up to 100, making it 1 meter. Now, each of these little 0.1 or 1, 2, 3, each of those is a centimeter. If you took 1 centimeter, and I did it for you right here, I took 1 centimeter and you cubed it. Just bear with me, I didn't tape this together good. I wanted to leave it open. But if you cube it and you fill it up with water, the weight of that water equals 1 gram. Gram is our international unit of weight. So we just did length, we did weight. The volume would be liquids like what you call a gallon, right? So in the metric or the standard unit of volume is liter. So everything came from this, everything we've talked about so far. A liter is 10 centimeters by 10 centimeters by 10 centimeters. You fill up a 10 centimeter cube with a liquid, you have exactly 1 liter. So science tried to make our units of measuring easy. They tried to make it easy for themselves. They tried to make it easy for everybody. This is why the whole world is on it. So now if the whole world is on it, then why aren't we on it? Why isn't the United States doing this? Well, according to the National Institute of Standards and Technology, we are. And we've been doing it for a long, well, we'll get to that. We've been doing it for a while. But according to the United States National Institute of Standards and Technology, they say that the United States government defines our customary units. They define our customary units as metric units. So that means if you said, hey, Mr. United States government, what is your gallon? Mr. United States government would say, oh, our gallon is 3.875 liters. That's what our gallon is. That's how we define it. Same thing with a pound is 0.45359 kilograms. It's defined in these international units, and our foot is 0.3048 meters. So, when did that happen? It sounds like we're getting on board with this. It sounds like this is a real thing. Did Trump do that? Did Obama do that? Well, no. Ulysses S. Grant did that back in 1875. So we've been on the metric system technically since 1875. But yet we still use this. So what does that all mean? Well, all right, we learned about where it came from. We learned about how long we've been technically on the metric system. Does that mean that one day I'll be able to look at this and instead of using fractions, I'll be able to see numbers broken down by hundreds in a decimal system? I'm doubtful, but hopeful.